Write the rational expression in simplest forms. We have x squared minus 1 over x cubed plus x squared plus 25x plus 25. The numerator is a difference of two squares. Take the square root of each term. We have x and 1. Put in plus and minus signs to complete the factoring. In the denominator, we have x squared in common with the first two terms. X cubed divided by x squared is x. X squared divided by x squared is 1. Bring down the sign in the middle. The back two terms are divisible by 25. 25x divided by 25 is x. 25 divided by 25 is 1. We have created matching factors. We'll make a copy of x plus 1. X squared plus 25 came from each pair, and that'll make up your second factor. We have matching factors in the numerator and denominator, so those can be canceled, and that leaves us with x minus 1 on top and x squared plus 25 on bottom. Be careful, don't cancel any of the x's. Only factors, not partials. If you're asked to multiply rational expressions, then we're going to start by factoring as much as we can. This top left part, x squared minus x minus 20, we take factors of 20 that add up to negative 1. Negative 5 times positive 4 is negative 20. Negative 5 plus 4 is negative 1. So the top left term, that trinomial, will factor as x minus 5 times x plus 4. In the bottom left, that trinomial, we need factors of 25 that add up to 10. A couple of 5s will do it. 5 plus 5 is 10. 5 times 5 is 25. In the upper right, x plus 5, that doesn't have anything in common. You could factor out a 1, but it doesn't lead anywhere. Bottom right is a difference of two squares, so you take the square root of each term, that's x and 4, put in a plus minus sign, and you've completed that. Any factor from the top that looks like any factor from the bottom can be canceled. Be careful, it's a one-on-one cancellation. This one survives. X plus 4, same on top and bottom, cancel. We have an x minus 5 as a remaining factor on top. X plus 5 times x minus 4, we have two remaining factors in the denominator. But once you've canceled all your common factors, whatever doesn't cancel makes up your final answer. If you're asked to divide, what I would recommend is immediately change to multiplication, flip the fraction on the right. X, we don't do any factoring with it. X minus 5, it only has a factor of 1 in common, so I don't even want to factor it. X squared minus 25, now that's a difference of two squares. That will factor as x plus 5, x minus 5. And then x squared, I'm going to make it come down here. It stays in the bottom right. We can cancel a single x with a single x, so that leaves 1 in the bottom. X plus 5 times x minus 5, we can cancel an x minus 5. What we're left with is x plus 5 on top and an x to the first after that cancellation on bottom. If you're asked to subtract rational expressions and the denominators match, then that's really good. That's your best case scenario. Let's write all of this as one fraction with a common denominator of x plus 2. We have x minus 1, subtract x, subtract negative 6, subtract x, subtract negative 6. That makes a positive 6. This x minus that x minus x is 0. Negative 1 plus 6 is 5. So after you combine like terms in the numerator, all that remains is a 5. In the denominator, we have x plus 2, and that's your final answer. That's the simplify part. With subtraction, you have to be careful to subtract each term in the second fraction's numerator. Where it gets rough is if you're asked to subtract and you don't have a common denominator. X over x plus 2 minus 6 over x minus 1. If your denominators don't match, then what we're going to do is we're going to use multiplication by a well-written 1 to create a matching denominator. The easiest way for me to tell you to do it is take the denominator you already have and multiply in the denominator that you don't have. X minus 1 over x minus 1 is actually a value of 1. If you multiply something by 1, it stays the same. So all I'm doing is taking the first fraction and multiplying it by a specific 1. That 1 is the other denominator. And then you do that for the second fraction. We have 6 over x minus 1. I've left that in the black ink. The other denominator is x plus 2. If you write it on top and bottom, all you're doing is multiplying by 1. It just doesn't look like a 1. But what you've done is you've forced the same denominator into both fractions. Excuse me. X times x minus 1 is x squared minus x over the denominator that we forced. 6 times x, 6 times 2, that's 6x plus 12, over the denominator that we have forced to be common. Notice that now our denominators match. Cautious with the minus sign. That's going to be x squared minus x. You copy your first numerator, distribute the minus sign. We're going to subtract 6x, and we're going to subtract a 12. These two terms add up to negative 7x, and everything else gets copied. So we have x squared, a total of minus 7x's, minus 12. Our denominator stays the same. It looks like we should be able to factor our numerator, but we can't. If you take factors of 12 that add up to 7, you could use 4 and 3. The problem is, in order to get 4 and 3 to add up to negative 7, they both need to be negative. But what happens when you multiply a negative 3 and a negative 4? You don't get negative 12. So we can't find a couple of good numbers that work out. And that's okay. They don't always simplify. That's the most we can do with this problem. And then finally, we have a distance and midpoint problem where you're asked to find the distance between 2 points and the point halfway between them. Let's start with distance. If you plot negative 4, 5 and 8, 0, you will land at these two places, negative 4, 5. So from the origin, left 4, up 5, that takes us here. The other point, 8, 0, that's 8 to the right. Don't go up or down because the y-coordinate is 0. These 2 points, if you connect with a line segment, is that pink line segment here. Now, a lot of you in class had heard of Pythagorean theorem, and distance formula spawns from that. Using distance formula, you have a large square root term. You subtract your x's, negative 4 minus 8 squared, plus, And then you subtract your y coordinates. 5 minus 0 squared. That's negative 12 squared, which is 144. This gives us 5 squared, which is 25. Those two numbers have a sum of 169, and that has a square root of 13. So these 2 points are 13 units apart. Now, back to the Pythagorean theorem part of this, if you wanted to find distance using Pythagorean theorem, that's totally fine too. Let me go over that real briefly. If you take your line segment that connects the 2 points given in your problem, and you construct a right triangle based on those 2 points, you would have a vertical leg of 5 units, a horizontal leg of 12 units. 5 squared plus 12 squared equals your hypotenuse squared. That's this upper right equation. I let x be the hypotenuse. 5 squared plus 12 squared equals hypotenuse squared. Well, 25 and 144, that adds up to 169. Take the square root and you get square root of 169, which is 13. That's just another way to get distance. Notice that this vertical leg 5 matches this difference in y's. This horizontal leg of 12 matches the horizontal distance from negative 4 to 8. And that's all subtraction is. It's the distance between two numbers. 5 minus 0 has a distance of 5. 8 minus negative 4, that has a distance of 12. Now, moving forward with midpoint, midpoint is just taking the average. If we go back to the original 2 points of negative 4, 5 and 8, 0, we're looking for the point exactly halfway between. In class, we made the discovery that suppose you have 2 test scores, one is a 90 and one of them's 100. If you add those up and divide by 2, then you get 95. And that's exactly how you calculate a midpoint. You take the average of your x's, so negative 4 plus 8, add your x's, divide by 2. Then you average your y's, add up your y's, 5 plus 0, divide by 2. That gives us 4 over 2, which is 2, and 5 over 2, which is 2.5. It's totally fine to leave it 5 over 2. If you go to this location, starting at the origin, if you go right 2, up 2.5, you have found the midpoint of the line segment connecting the original points from your problem.